Two lighthouses are 20 miles apart on a north-south line. So a north-south line, this is a north-south line, and I have a lighthouse here and a lighthouse here, and they're 20 miles apart. A ship is located 85 degrees east of north from one lighthouse. So this is north going this direction, north, but we have to go east 85 degrees. So 85 degrees is more likely around right here. So 85 degrees. And then the other lighthouse is 128 east of south. So south is this way, and you're going to go east, which is this direction. This is about 128 degrees. Okay, so let me draw this a little better so I can make my triangle. There we go. All right. Is that okay so far? How we set it up? So that's my triangle. Find the distance from the ship to each lighthouse. So the ship is out here, and I need to find the distance from here to here, and the distance from here to here. Okay, so let's figure out these angles. If this is 85 degrees, 180 minus 85 is 95. So this is a 95-degree angle inside of here. Then 180 minus 128 is 52 degrees. So this is a 52-degree angle in here. So since I have 95 degrees and 52 degrees, I can add those together and subtract it from 180. So this is a 33-degree angle. Okay, did I do my little math right? Okay, correct me if I'm wrong. Okay, so now I can use law of sines because I have a pair. I have angle 33 across from its side 20. So I can do sine of 33 with the 20. And I'll label this A. We can find side A and side B. I'll do B first. Do the smaller one first. So B over, and this is across from B is angle 52, so sine of 52. And then you solve for B. So I'm going to multiply both sides by sine 52. Those cancel. Sine 52. So I'm going to type this into the calculator. So when you type that in, let me know what you get. So when you type this in, you'll get 28.937 miles. Okay, so you found one of them. Your other one, we still have sine of 33 with its side 20. And now let's find the longest side, A. I know that's the longest side because it's across from the biggest angle, sine 95. So multiply both sides by sine of 95. Those cancel. Sine of 95. So type this into the calculator and you get 36.5818, which you can round to the nearest thousandths. So 582 degrees. Oh, these aren't degrees, sorry. These are miles. So this side is 36.582 miles. One flies due east. So guys, let me draw you a compass. This way is north. This way is east. So if it just goes east, assume that it's going all the way east. They didn't tell you the degree. So this is a 90 degrees right here. So this went 90 degrees east, due east, at 350 miles per hour. The other flies at a bearing of 70 degrees. So let me draw this. This is your compass right here. We're going to start both planes right here. One of them goes at a bearing of 70 degrees. So I'm going to say that this is 70 degrees. And the other one went due east. So they just went straight east. That forms a 90-degree angle. So this plane, I'll call it B, this one I'll call it A. All right, so if this one went 90 degrees and this one went 70 degrees, what's the angle between them? 90 minus 70, that's 20 degrees between them. Okay, so that's my picture. So the one who went 70 degrees, it's going 380 miles per hour. So I'm going to do 380 miles per hour. And this one that went 90 degrees, because they went straight east, is 350 miles per hour. Okay, and it says, how far apart are the planes? So I want to know this distance. How far apart are the planes after 2 hours? So I'm going to multiply this by 2 hours and multiply this by 2 hours. Hours cancels with hours. 350 times 2 is 700 miles. So this is, I'll write it in a different color. This is 700 miles. And then what's 380 times 2? 760. So this will be 760 miles after 2 hours. Hours cancels with hours. Okay, so now I can go ahead and use one of my formulas. Which formula do you think we can use? Yep, it's going to have to be law of cosines because I only have one angle here. Okay, and I don't have any families. I know this angle, but I don't know its side. I know this side, but I don't know its angle. I know this side, but I don't know its angle. Okay, so we're going to have to do law of cosines. All right. So law of cosines, I'll put it over here. I'm going to have 380 squared plus, this isn't 380. We said it's 760. So 760 plus 700 squared minus 2 times 760, 700 cosine of 20. And that'll give you this side right here. You'll need to put that under the square root symbol. So type it just like that into your calculator, and you'll get 260.321 miles. 260 and 321 thousandths miles. Okay, so angle of elevation, that means you're looking up and it's 31 degrees from point P. It's 65 yards from a tree. So it's 65 yards from the tree. So the top of the tree is 31 degrees. So we have that. And the tree leans 7 degrees away from P. So it's not leaning straight up. It's kind of at an angle. So this is a 90-degree angle if it was standing straight up, but the tree is a little bit slanted 7 degrees. So what's this whole angle? 97. So this is a 97-degree angle, not a 90-degree. And it says, how tall is the tree? So I want to know what this side is. I would like to know this side, how tall the tree is. So I can use law of sines. I can figure out this third angle by doing 97 plus 31, 128. So 180 minus 128 is 52. So this missing angle is 52 degrees. Okay, so now I have a full set. I have this angle along with its side. So then I can do law of sines. So I'll do 65 yards over sine of 52 equals this height that I want to know, the height of the tree. Across from that is this angle 31. So sine of 31. And then you solve for the height. So I'm going to multiply both sides by sine 31. Sine 31. So type this into your calculator and you should get 42.4835 yards. which you can round to the nearest thousandths. So this will become a 4. So you'll do 42.484 yards. Okay, so two meteorologists are 25 miles apart, located on an east-west road. So here's one meteorologist, I'll say A and B, and they're 25 miles apart. Meteorologist A, who is on the left, cites a tornado 38 degrees east of north. So if this is north, east would be going this direction, 38 degrees. So it would look something like that. Meteorologist B, who is on the right, cites the same tornado 53 degrees west of north. So if this is north, he's going west this direction, 53 degrees. So I'll say like this. So this angle is 53 degrees. And guys, this is a compass. This is north and this is east, right? So that's a 90-degree angle. This is north and this going this direction is west. That's 90 degrees. So if this is to find this inside angle, I'm going to do 90 minus 38. And I get 52. So this is 52 degrees in here. And then 90 minus 53, I'll get 37 degrees here. All right. And since I have 2 degrees in my triangle, I can find the third degree by adding 52 and 37 together. So that's 89 degrees, and I'm going to subtract that from 180. And you guys can use a calculator for all of this. So this is 17 minus 8. What do y'all get? 91. So this is 91 degrees up here. All right. So that is my picture. I figured out all my angles. Let's look at the question. It says, find the distance from each meteorologist to the tornado. So this is where the tornado is up here. So I want to find this side and this side. So I'm going to go ahead and use law of sines. The reason why I'm going to do law of sines is because I have 90-degree angles and I have the side that it's paired with. I have a complete set. I have a set of side and angle. So I can do law of sines. So law of sines, I have 25 paired with 91 degrees. Uh-oh. And I don't know this side, so I'll call this side A, since it's across from meteorologist A, or angle A. In fact, I won't confuse you guys. I'll just call this X. And that is across from sine 52. And then you're going to type this into your calculator. So multiply both sides by sine 52. Sine 52. Type this into your calculator, and you'll get the distance that meteorologist B is from the tornado. And you're going to get 19.705 miles. So this is how far, or the distance that meteorologist B, distance from B. Okay, and if you want to find the other angle, do law of sines again. I'll do sine 91 with 25 and sine of 37, because that is across from this side. I'll call it Y. Multiply both sides by sine of 37, sine of 37. Type this into your calculator and you will get 15.048 miles. So if I add that to my picture, this side is 15.048 miles. And this one is 19.705 miles. So guys, I have triangle VWX, and these are the different side measurements of the triangle. And they want us to find angle W. So this is a side case. I'm going to go ahead and do the law of sines. So I want to find angle W. So this is my formula. 130 squared plus 730 squared minus 2, 130, 730, cosine of W, because I want to find cosine W. That means the side W will go on the outside. These have to match. This is side W and cosine W, the angle. I'll make this a capital W so you know this is the angle W. Okay, and then the other sides, they just go in here. Okay, so now we're just going to solve. So this is what you're going to put into your calculator. First, you're going to have to subtract 130 squared. Subtract it from this side. Subtract that from the other side as well. So I'm going to have 780 squared. I don't know why this is a cube. That should be a squared. Minus 130 squared minus 730 squared is equal to all of this. Now, how do I get cosine W by itself? Yep, I divide all of these numbers. So -2, 130, 730. Those cancel out. I'm going to divide this side by -2 times 130 times 730. Okay, so this is what I have. 780 squared equals cosine W. Now, how do I get W by itself? What do I do to both sides? Cosine inverse. Those cancel. Now do the cosine inverse of this side. You're going to type all of this into your calculator. Type all of this into your calculator. And that will give you W. Okay, so when it was typed in, we got 108 degrees. So that is angle W.